Hello friends, welcome to my channel Concept with Clarity 1. Today in this lecture we will try to see basic gates using CMOS Logic Family. Design of basic gates using CMOS Logic Family. What are basic logic gates? One is NOT gate, second one is AND gate, third one is OR gate, right? So first of all, we already know that a logic family is nothing but implementing the logic gates by using transistors or FET, right? We already know a CMOS transistor, one simple CMOS transistor which is also called as CMOS inverter. CMOS transistor is equal to CMOS inverter. So what is a CMOS transistor? CMOS transistor is a combination of one PMOS transistor and one NMOS transistor, right? We know this as the connection. In the last lecture also we have seen, right? So this is an CMOS transistor and we have proved this as an inverter operation also. So what is the action? If I take V in input, PMOS, NMOS and V out as the output, right? So when V in is equals to 0, right, my PMOS will be on, my NMOS will be off, and the output I get as an 1, that is plus 5 volts, that is VDD. How? Because PMOS is on, this is on and this is off, right? So my VDD will be flowing to V out, hence my V out will be equal to 1. Similarly, when my input is equals to 1, right? So my PMOS will be off, NMOS will be on, and I get an 0 output. See here, NMOS is on, PMOS is off. So whatever the input is given, that will be flowing to the ground, hence I get an 0 output. So this is how, if you see, if I give an 0 input, then my output is equals to 1, and if I give an 1 as an input, then the output is equals to 0. Hence this CMOS transistor is nothing but CMOS inverter, and that is how a NOT gate is implemented by using CMOS logic family, right? And coming to the other gates, okay, first of all let us realize the NAND gate, then we will realize the AND gate. Okay, we will put an inverter at the output of and NAND gate such that it behaves as an AND gate, right? So what is the symbol of the NAND gate? This is the symbol of the NAND gate, right? So if I give A and B as the input, then I get A into B whole bar, okay, and the truth table goes like this: A, B, A into B whole bar, okay. So 0 0 0 1 1 0 1 1, right? So this one, you see, for the AND gate it is 0 0 0 1 and this will be 1 1 1 0, okay, the output. Now let us try to see the implementation of NAND gate by using PMOS transistors, that is CMOS transistors. So here for an NAND gate, two PMOS transistors and two NMOS transistors are used. A total of 4 transistors are used, okay, to construct an NAND gate, in which PMOS is connected, PMOS transistors, okay, PMOS transistors are connected in parallel and NMOS transistors are connected in series. Okay, so you know the PMOS transistors are always in the above the demarcation line, and the NMOS transistors are below the demarcation line. Okay, so we'll try to draw the diagram here. So you see here, PMOS transistors are connected in parallel. You simply draw a demarcation line, and above the demarcation line you have the PMOS transistors. All the PMOS transistors that might be in series or parallel, you connect it above the demarcation line, and below the demarcation line you will be having the NMOS transistors. Okay, so this is the demarcation line we have drawn, and let us try to draw the implementation now. So here my PMOS transistors, I have PMOS transistors are connected in parallel, and NMOS transistors, let us take the other one, are connected in series. Okay, now let us try to connect all these things. So this is connection. Here I will give the VDD. Okay, and here I will connect it, and simply I will give it to here, and from this point we take the V out. From this point we take the V out, right? So now you see here two inputs, right? So one input is one A input of PMOS transistor and NMOS transistor. This is B input of PMOS transistor, and this is NMOS transistor. Okay, so for our convenience I have written A and A here, but internally this is actually connected. This is wired connection, right? And this is also a wired connection. Okay, this is what, right? So the structure looks like this. Now let us try to implement or check the logic here. Okay, what happens when the inputs are given? So when the input is 0 0 here, when the input is 0 0, okay, PMOS will be on, NMOS will be off. Both the transistors are off now, right? Since both the transistors are off, this is open circuit, this is open circuit, right? This is short circuited. So because this is short circuited, even if one of the transistor is on, then VDD will be flowing to V out. VDD will be flowing to V out, even if one of the transistor is on. Okay, that means 0 0 case, 0 1 case, 1 0 case. In PMOS transistor, if even one of the transistor is on, my VDD will be flowing to V out, right? Now whenever both the inputs are 1 1, then what happens? Then what happens is both PMOS transistors are off, and this is short circuited, right? So whatever the input is given to A, whatever the input is given to B, that will be flowing to the ground, hence my output will be equal to 0, right? So similarly, that is why that is how a NAND gate is implemented. Similarly, we can implement a AND gate also. AND gate. So what you will do, I have a PMOS transistor here connected here. This is a simple NAND gate. NMOS is connected in series, right? So this is VDD, and the connections are like this. Okay, so from here, from the middle part, I will take the V out, right? So this is my input A, this is my input B, A and B. Okay, this is NAND gate output. Okay, the output here is A into B whole bar. Okay, now what we have to do, I need to connect an inverter here. Okay, I need to connect an inverter. We already know how an inverter is connected. That is nothing but a single CMOS transistor here. Connect a single CMOS transistor such that this acts as an inverter. So I will connect directly VDD here. okay, and this is my final output V out. Okay, V out here it is A into B. Okay, A into B. So this is how an AND gate is created, okay, implemented by using CMOS logic family. Similarly, I can also implement NOR gate using CMOS logic family, in which my PMOS transistors are connected in series, NMOS transistors are connected in parallel. Okay, so series connection of PMOS transistors, you carefully observe here, this is VDD, and parallel connection of NMOS transistors, you can see here, right. So the connections goes like this. This I can give it to ground, and this is my V out. Okay, so my input A, B, A and B. Okay, so same thing, if you see the truth table, A, B, this is first of all NOR gate, right. This is A plus B whole bar, A plus B whole bar. Okay, 0 0 0 1 1 0 1 1. So what is A plus B whole bar? That means NOR gate output. So this is equal to 1 and the rest of the outputs are 0. Rest of the outputs are 0. Okay, complementary of OR gate, right. So we will see the action here. So when the inputs are 0 0, when the inputs are 0 0, 0 0 means both are on. If A is equals to 0, B is equals to 0 and both transistors are on, and this will be equal to off, right. So because this is on, both transistors are on, hence my VDD will be flowing to V out, because these are open circuited, right. Now what happens, even if one of the input is 0 and one of the input is 1, even if the one of the input is 1, then my transistor will be on here, right. So let us take, if A is equals to 0, that means this is on, and B is equals to 1, for 1 this is equal to off, right, this is off, that means this is open circuit. And see here, A is equals to 0 means this is open circuit, B equal to 1 means, so whatever the 1 is there, whatever I have applied here, that will be flowing to VDD, hence my V out will be equal to 0. That means even if one of the input is 0, then my outputs are equal to 0 0. Hence this is how we implement a NOR gate using CMOS logic family. 2 PMOS transistors and 2 NMOS transistors. PMOS transistors are connected in series, NMOS transistors are connected in parallel. Similarly, if I wanted to convert this into AND gate, what I will do, I will simply connect, you see here, I will draw the diagram once again. You can see here, so this is A, B, A and B. Okay, the output here is again connected to a CMOS transistor, that is CMOS inverter. This is again VDD, hence I will get an A plus B output here, that is OR gate output. OR gate output you will be getting. So this is how we implement the basic gates using CMOS logic family. So if you like the concept, please, if you have understood the concept, please like the video, share and subscribe. Thank you.